Good morning, guys. So today we're going to start working with something that I don't know if you guys have ever heard of or have ever seen, but it's a lesson that's called trigonometric ratios. And it's something that we're actually going to be working with for the next couple of lessons just because they are extremely important as you guys actually go through to future math classes in terms of like pre-calculus and all that. You will be utilizing trigonometric ratios. This is one of those things that does come up a lot because it is extremely important in terms of practicality, what we use them for, how we can use them to solve for certain measurements that we may not know. But what I want to do today is I want to start working with the basics because, again, since we're going to work for it a few days, I got to make sure that you guys at least understand, one, what it looks like, and two, how to properly start analyzing and setting them up, okay? So when we're talking about trigonometric ratios, we're talking about three of them. We're talking about something that's called sine, right? Talking about cosine, and we're talking about something that's tangent. So when we have these three, right? These three trigonometric ratios, they all relate to a right triangle. Again, we've been working with right triangles now for a few weeks. Right triangles can only be applied with trigonometric ratios. It can't be any other triangle, right? So what we use trigonometric ratios is when we have a triangle, we use them in order to be able to solve for missing sides. We're able to use them to solve for missing angles, right? All of that, any part, as long as certain information is given on a triangle, we can use these three trigonometric ratios. We can't use them all the time because it all depends on what information we have. But again, it's one of those things where you have to analyze which one you're going to use, how to properly set it up and all that. But I need to get you guys comfortable with just being able to look at them so we can actually start using them in the lessons going ahead, right? So when we're looking at these, all three of these all relate again to a right triangle, right? And it has to be a right triangle. Because if it's not a right triangle, we cannot use any of these, right? And all of this has certain relationships, right? Sine has a certain relationship, cosine has a certain relationship, tangent has a certain relationship, right? And what I mean by that, the relationship of sine is opposite over adjacent. And that refers to sides, right? And again, we're going to go more into it, and I will show you that sine represents the opposite side over the adjacent, right? Cosine represents adjacent over the, oh, I'm sorry, guys. I apologize. Sine is not opposite over adjacent. I'm sorry. It's opposite over hypotenuse, guys. Over hypotenuse. Right? Cosine is adjacent over hypotenuse. Hypotenuse. And then the tangent is going to end up being opposite over adjacent. Opposite over adjacent. And again, it's one of those things that some people will remember these easily. Other people will find it necessary to memorize them. I want you guys comfortable with being able to use them properly and setting them up, right? So again, opposite, adjacent, hypotenuse, all that refers to the sides on the triangle, right? Because triangle has three sides. Whenever we have a triangle, and when we set it up, one side's going to be opposite, one side's going to be adjacent, one side's going to be the hypotenuse. The hypotenuse, all of you should always know. Hypotenuse is always going to be the longest side, which doesn't matter whether you're looking at the triangle one way or looking at it another way. The hypotenuse is always the longest side, right? This would be our hypotenuse in this case, okay? And we know it's the hypotenuse because it's across from the right angle, right? So the hypotenuse, always the longest side. But first thing I would tell you, make sure you guys familiarize yourselves with those formulas because we're going to be using them a lot. And now, I want to show you where the opposite comes from, where the adjacent comes from, and the hypotenuse in relation to given angles, right? Because all of this relies on a given angle, right? And I'm going to show you what I mean. I'm also going to erase these because, again, I do want to rewrite them again in relationship to a given angle, right? So first thing, let's look here, right? We have a triangle, right? And I'm going to start being very specific. It's got to be a right triangle again. Let's call this one here, let's call that angle not necessary yet. Let's call this angle C, let's call this angle E, and let's call this angle A, right? So we have three angles on a triangle, angle C, angle E, angle A, right? And I'm going to put some numbers here as well. I'll forget the numbers for now. We know, again, we have sine, right? We have cosine, and we have tangent, right? We have those three. And all three of those are all, again, it's all in relation to a given angle, because whenever we're working with this, it all depends on the angle we're working with. In this case, we're going to work with angle A, right? We're going to focus just on angle A, because again, it all depends. You can use sine, cosine, and tangent for angle A. You can use sine, cosine, and tangent for angle C. We're going to work with just angle A, because all of that does matter when we actually set it up, because you need a focal point, right? You need a point to focus on. You need to know that A is the angle we're working with. And again, just to revisit it, sine of A, whenever we're working with sine, and these are just abbreviations, guys. Sine means opposite over hypotenuse, right? Cosine means adjacent over hypotenuse. And tangent means opposite over adjacent, right? Again, just ways to familiarize ourselves. And let's start analyzing, because all of this, again, depends on angle A. And the one thing we know when we're labeling this, the easiest, we have three sides, the opposite side, the adjacent side, the hypotenuse, right? Out of all three of these sides, doesn't matter. We know automatically that the longest side is this one. That's the hypotenuse, right? That's our hypotenuse. Now we have the opposite side and we have the adjacent side. For me, it's easier to explain sometimes the adjacent side because people see it better. Adjacent just means next to, right? The word adjacent means right next to. So if I'm talking about, we know that this side is the hypotenuse, which means of these two, one's the adjacent side, one's the opposite side, right? And we're talking about angle A. So if we look at it, adjacent means next to. Which side is next to A? We have this side, which is not next to A, and then we have this side here, which is next to A. So we know that this side here is the adjacent, right? That's my adjacent side because this side is next to A, right? Which means if that's adjacent, that's hypotenuse, this side here is going to be my opposite. That's my opposite side right there. Because again, it is literally opposite angle A. It's across from angle A. So in doing this, it's the most important thing that I can teach you, because once you figure this out, everything else becomes really easy to do, guys. Extremely easy to do. Because again, we have our focal point A. We know that our hypotenuse is always our longest side, always across from the right angle. We know that adjacent means next to, so we know that this side is next to A. And we know that this side here is opposite of A because it's across from it, right? And once you have that labeled, it all becomes very easy. Now let me show you what I mean by easy. And again, all of this is just dependent on A. Because let's say that I was to now work with angle C, that would still be my hypotenuse. But now if this is angle C, right, we know that this no longer is opposite C. This now becomes adjacent to C, becomes next to C. So again, it always depends on the angle. We always need to give you an angle that you're working with, right? Now again, let me show you how you actually use this now to start setting up formulas, to start setting up the ratios to solve, right? I'm going to give you a triangle again. Right? And now I'm going to give you measurements on this triangle. Again, it's always got to be a right angle. That's going to be H, that's going to be L, that's going to be M. Right? I'm going to say that this here is 3, that's 4, that's 5. And so what I'm going to tell you, again, it sounds a little complicated at first. I'm going to want you to find the sine of L. I'm going to want you to find the cosine of L. And I'm going to want you to find the tangent of L. And again, some people may be thinking, how do I actually find the sine, the cosine, and the tangent of L? I'm going to put this down here, just for you guys to remember, right? We know that sine equals opposite over hypotenuse, right? Sine is opposite over hypotenuse. We know that cosine equals adjacent over hypotenuse. And we know that tangent equals opposite over adjacent, right? Again, just here for us to help remember, right? We have the tangent, we have the cosine, and we have the sine, right? We have those three right there. And we want to set them up. We want to set up sine of L, we want to set up cosine of L, we want to set up tangent of L. So looking at all that, we know what angle we're working with. We're working with angle L, right? So my advice to you, put a mark right there, something to help you focus on angle L, because that's the angle we're working with. Since we're working with angle L, before we can figure out what all of these are going to be now with numbers, label. Because once you label, everything becomes easy, guys. So again, we're working with angle L. Out of those three sides, we know that this is my hypotenuse, and we know it's the hypotenuse because it's the longest side out of all three, right? And again, crossing the right angle. We now have the opposite side and adjacent. And again, we're working with L. So when we think of adjacent, what side is next to L? Is the 3 next to L? Is the 4 next to L? We see that 4 is adjacent to L. It's right next to it, right? So we know that the 4 is adjacent. And we know that 3 is going to be opposite. Because again, it's across from angle L, right? 4 is adjacent to angle L. Hypotenuse is longest side, right? And some people may think too, isn't the hypotenuse also adjacent to L? It is adjacent to L, but remember, the hypotenuse is the longest side. There's only one longest side. That's why we label that first, right? So now once you have this, all it is now, it's just setting it up, guys, which is very easy. So if we want to find sine of L, remember, sine is opposite over hypotenuse. So the opposite is 3. The hypotenuse is 5. And that's it. That's how we set it up. It's literally opposite over hypotenuse. Opposite over hypotenuse, that's our formula. And that's what sine of L is. To find cosine of L, cosine is adjacent over hypotenuse. So it would be adjacent 4 over hypotenuse, 5. And cosine of L is set up. And now tangent of L is opposite over adjacent. Opposite is 3. Adjacent is 4. And we're done. That's all it is, guys. All it is literally, again, being able to figure out what's opposite, what's adjacent, what's the hypotenuse. Because once you do that, all of this becomes very easy to set up because it's just following the formulas. And again, the importance of today's lesson is just being able to set all this up, guys, because without being able to set it up, we're not going to be able to know how to use them for the next few lessons going forward, okay? So the most important thing of today is knowing how to set these up. Knowing how to properly know what's my opposite side, what's my adjacent side, what's my hypotenuse in relationship to the angle that they give you, right? Because now once we have this, we're able to figure out missing angles. We're able to figure out also sides when they give us limited information, all of that, right? And again, I want you guys to feel comfortable with this. I am going to do another one just to show you as well that sometimes these things differ. And it's not always the same. Again, L is what we're working with. If we had been working with H, it would have been completely different, all right? But I do want you guys to get on the hang of it. And the other thing I also do want to mention to you guys, there's one angle that you can never work with when you're trying to find sine, cosine, or tangent, and that's the right angle. You can never use the right angle for sine, cosine, and tangent, just because if we're working with the right angle, we don't know what side is adjacent. Technically 3 would be adjacent to M, right? It's next to it. Technically 4 would be adjacent to M. Technically our opposite side would be the hypotenuse, which can never happen. So the one angle out of all of these, you can never use the right angle, never. You can use H, you can use L, but we can never use the right angle, okay? And let me do one more of these just to show you. I'm gonna leave those formulas there now, just to actually get you guys seeing them. And again, remembering them, right? Let me do one more. So I'm going to give you a triangle. Right. Triangle there. I'm going to call this angle G. I'm going to call this angle K. I'm going to call this angle P. Right? And again, we need a right angle. And I'm going to make this 5. I'm going to make this 12. And I'm going to make this 13. And I'm going to ask you just to set up sine of P, cosine of P, and tangent of P. Right? I want to set up those three. So again, looking at that, we automatically know already what angle we're working with because it will always tell us what angle we're working with. And in this case, we are working with angle P, right? So now knowing we're working with angle P, again, put a marker there just to help you guys out, right? We need to now identify opposite side, adjacent side, hypotenuse. Out of all of those, we know that the hypotenuse is 13, the longest side, right? We know that the adjacent side, again, adjacent to P, because we're working with P. We know that the side next to P is the 12, right? Because they're next to each other, they're adjacent. We know that the opposite side is 5, because again, it's opposite of angle P, it's across from angle P. And now once we have that, just substituting them, right? Sine is opposite over hypotenuse, opposite is 5, hypotenuse is 13. Okay? Cosine is adjacent over hypotenuse, so cosine is going to be 12 adjacent over hypotenuse 13. Tangent, opposite over adjacent, we know that the opposite is 5. We know that adjacent is 12. And that's that, guys. It's how we set it up properly. And again, it always depends on what the angle is, right? Because it does make a difference. Because now if I was to work with angle G, this is what I'm trying to tell you. If we were to work with angle G, that's still our hypotenuse. But now, if it's angle G, this now would be our opposite side, not adjacent anymore, because this is not next to 12, is not next to G. And the 5 would now become adjacent, because again, the 5 is next to G. Always remember, all depends on the angle you're working with, and all these relationships only apply to the angle. If they switch it up, make sure you actually analyze the information further. But going forward, we're going to show you then on the next lesson how to use all this to solve for missing sides. The lesson after that, I'm going to show you how to use this to solve for missing angles. Again, hope this helped. Let me know if you guys have any issues. Take care.